Good afternoon and welcome to Top Lessons Learned while researching and writing the DevOps Handbook with Jean Kim. Just a brief note about eSynergy before the presentation. eSynergy specializes in open source and cloud resourcing. If you are looking for a new opportunity or to build out your team, please get in touch after the webinar. Now, moving on to some housekeeping. If you have any questions for Jean, please fire them over via the questions box throughout, and Jean will answer them at the end of his talk. We are recording the session, and the slides and recording will be made available and sent to you by email along with my contact details. Now, I'm going to pass over to Jean to begin the talk.
Thank you so much, Araya. My name is Jean Kim. I've had the privilege of studying high-performing technology organizations since 1999, so it's a 17-year journey that's been full of surprises, but perhaps the largest surprise for me was that it took me straight into the heart of the DevOps movement, and so many years ago I wrote a book called The Phoenix Project, came out in 2013 with Kevin Baer and George Spafford. And more recently, what I'm going to be talking about today is a book that it will be coming out in about 2 weeks. And Ryan, if you go to the next slide, that is the DevOps Handbook. And I cannot overstate how much I've learned since 2013. This is a book that we co-authored with Jez Humble, so he's most well known for his famous book Continuous Delivery. Patrick Dubois, who probably needs no introduction, we often call him the godfather of the DevOps community, and is credited rightly for helping coin the term DevOps back in 2008. And then John Willis, who is well known for many things, but I think many of us know him as Botcha Gloop on Twitter, and he was part of the team with Damon Edwards, who actually helped bring DevOps Days to the United States. So the DevOps Handbook, believe it or not, was actually supposed to come out before the Phoenix Project, so it's been over 5.5 years in the making. I'm just so thrilled with the way it's turned out. But maybe just to set the stage, I'm a big fan of this quote: "You're only as smart as the average of the top 5 people you hang out with." And so books are like many things in life. It really is a function of who your collaborators are. So I'd like to share with you in the next 40 minutes really my top learnings that came out of the DevOps Handbook. So Ryan, if we go to the first slide, let's go to the first big learning. And that really is that the value, the organizational value, the personal value of adopting DevOps is even higher than we thought. So this is based on work that I've done with Jez Humble, Dr. Nicole Forsgren, and Puppet Labs over the last 4 years now, where we have benchmarked over 26,000 organizations, really with the goal of identifying what does high performance look like and what are the behaviors that cause high performance. So in the next slide, I want to share with you the key metrics that really show that high-performing organizations that are adopting DevOps principles and patterns are massively outperforming their non-high-performing peers. These numbers get almost more and more absurd each year, especially around the agility measures. What we found was that high performers are performing 200 times more frequent deployments than the non-high performers. And that could be a deployment of code that's being checked into the code repository, or it could be a deployment of a change in the environment. But more importantly, they can complete those changes over 2,000 times faster than the peers. In other words, how quickly can we go from a change being introduced into version control through some sort of test cycle, through some sort of deployment cycle, and it's actually running in production. High performers can do it in minutes or worst case hours, whereas lower performers might require weeks, months, or quarters. So that's a 3-order magnitude difference in lead time. So on the next slide, Araya, we can show the agility. It's not just the agility measures, it's also the reliability measures. When high performers do a deployment, they're 3 times more likely to succeed without causing a Sev1 outage, a service impairment, a security breach, or a compliance failure. And when bad things do happen, they can fix it 24 times faster. And so this really gave us empirical evidence, year after year. But back when we did this in 2014, it really gave us the first really concrete evidence that really showed that you can be more agile and be more reliable at the same time. And in fact, if we want these sort of amazing reliability profiles, we have to do smaller deployments more frequently. On the next slide, Araya, this is actually statistics that are so new. This actually came out in the 2016 State of DevOps report, and it actually didn't make it into the handbook. So we found this other dimension of quality. So not only are high performers more agile, more reliable, but they're also spending half the time remediating security issues. In other words, by integrating all the information security objectives into every stage of the SDLC, they are getting far better security outcomes as well. And because they're doing such a great job in controlling unplanned work, they're being able to deploy 30% more time on new planned work. So those are the strategic activities as opposed to what is often firefighting in operations, test, information security, and development. So on the next slide, Araya, there's another, this is a surprise that we found out 2 years ago, is that not only do high performers have better IT performance, as defined by deployment frequency, lead time, change success rate, mean time to repair, they have better organizational performance. We found that high performers are twice as likely to exceed profitability, market share, and productivity goals. And for those nearly 1,000 organizations that gave us a stock ticker symbol, they had 50% higher market cap growth over 3 years. And just to calibrate this, I mean, in some ways this is really an absurd finding, because what we're essentially asking you to believe is that how a server administrator or how a developer performs their daily work can impact profitability, and it can even be visible in share price, which I think is asking a lot in terms of asking someone to believe. And yet, if we believe that how almost every organization these days, how we acquire our customers and how we deliver value to those customers is increasingly reliant upon the work that we do in technology, then maybe being 2,500 times quicker than our peers will create decisive winners and losers in the marketplace. And so I find that to be extremely believable and extremely compelling. And so I think this is, I find this actually very easy to believe. So that really is the first surprise, that the business value and the organizational value of adopting DevOps is even higher than we thought. So let's go to the next slide. The second surprise is understanding, or maybe getting a better insight into what the deploys per day metric really means. In the DevOps community, I think one of our favorite metrics is deploys per day. In fact, the famous Allspaw-Hammond presentation in 2009 at the Velocity conference about how Flickr was doing 10 deploys a day every day as part of the daily work, that shocked the world. In fact, as John Willis told me yesterday, as he recalled, people were almost throwing up in the back. They were so shocked by this. And we now know that 10 deploys a day, and in our benchmarking what we found is that 10 deploys a day is not considered that fast anymore. In fact, we would call it sort of mediocre among high performers. So the next slide, I still remember being in the audience in Velocity Conference 2010 when 2011, when John Jenkins from Amazon said that they were doing 15,000 deployments per day. So that's a deployment frequency. That's one deploy every 11.6 seconds. So that was shocking, at least to me. But that is not as shocking as what's revealed in the next slide. Ken Exner, the director of Dev Productivity at Amazon, revealed in the next slide, Araya, said by 2015 they are now performing 136,000 deployments per day. So that really begs the question of what is changing in these organizations that can explain this ever-increasing number of deployments per day. And it's not just Amazon, it's in every high performer. Araya, in the next slide, we can see that at Etsy, they describe how over the years they've gone from doing 30 deploys a day to 100 to now doing hundreds of deployments per day. You see this at Google, at Netflix, and so forth. So the surprising answer to that question of what is changing in these organizations, the answer is nothing. Nothing is changing except for one thing, which is the number of developers. So Araya, if you go to the next slide and build it out to show both metrics, I think the deploys per day metric is actually hiding the next metric. Araya, if you can build out the next element, yep, is deploys per day, I think, is actually hiding an even more important metric, which is deploys per day per developer. So we actually tested this in the 2015 State of DevOps research, and so in this case the population was about 6,000. And so if you go to the next slide, we can see what we found. So if you build it out one time, you can see on the y-axis is the number of deploys per day. If you, on the x-axis, if you can build out one more, is the number of developers. And what we found in the next build is that in the low performers, as we increase the number of developers, all right, one more please, as we increase the number of developers and low performers, the deploys per day goes down. In the next build, Araya, you can see then medium performers deploys per day remains constant. And in the next build, Araya, in the high performers, as we increase the number of developers, deploys per day goes up linearly. So what this shows us is that under certain conditions, DevOps enables us to, with the right architecture, with the right technical practices, the right cultural norms, we can actually scale developer productivity linearly with the number of developers. And the reason why I think this is so important is that so many of us were trained by the Frederick Brooks School of Thought, where he rightly pointed out our common experience in the mythical man month, that in general, as we increase the number of development teams, in general, we double the code integration effort, we double the test effort, and we double the effort required in order to deploy value to the customer. And so what this finding shows us is that, again, with the right conditions of architecture, technical practices, and cultural norms, we can actually scale developer productivity, as the number of developers grow. And there's no technology leader who doesn't care about maintaining and increasing engineering productivity. So Araya, on the next slide, that goes to my next big learning, is the importance of architecture. So another way to restate the graph from before is that what we want is not just high deploys per day, right? What we really want is to enable small teams to be able to work independently, developing, testing, and deploying value to customers without having to coordinate and signal and get approvals from hundreds or even thousands of other groups inside the organization. And so that is really a function of architecture. So on the next slide, Araya, there's 3 builds here. This graph comes from David Ashman. He was the chief architect at Blackboard. So they are the leading learning management system. So they sell to universities, or any place where the learners are, and really helping solve the faculty and students and the learners' objectives. And so this is for their flagship product called Blackboard Learn. So in the first build, we see that on the top is a number of lines of code in the repository. In the second line build, Araya, is the number of code commits per week. And so David Ashton showed this graph saying, holy cow, we have a problem here. And Araya, in the next build, he specifically looked at this. He said the uh-oh moment was around 2011 when he saw that the number of code commits happening in a given week were actually going down, and that the number of lines of code being added to the repository was actually flattening off, despite that the number of engineers were actually increasing. And so he saw that this means that the developer productivity was being degraded. The code integrations were getting increasingly difficult. The code release process was being increasingly difficult. And so he said this is an architectural problem. This is actually the most important problem that we need to solve that obstructs developer goals, testing goals, operations goals, and ultimately the goals of the customers. And so you can actually see the number of lines of code in the repo going down. So where did they go? All right, in the next slide, this is a separate code repository for what they called the building blocks. So building blocks is a modular place where if developers work within the building blocks, then they no longer have to communicate and coordinate and depend on other groups to do their work. And so you can see this exponential growth in the number of lines of code in the repo, because no sane developer would work in the big monolithic code base when there was a place where they could actually do work independently, where it's safer, and where small failures, small mistakes create small failures, whereas opposed to if you're in the tightly coupled monolithic code base, small failures can cause global catastrophic failures. So I think this is just one of the most dramatic examples of the concrete artifacts of tightly coupled architectures as represented in the last graph, and the characteristics you would see when small teams can independently develop, test, and deploy value to customers. In the next slide, Araya, there's a famous principle called Conway's Law that has become very prevalent in many DevOps conversations and DevOps presentations, DevOps conferences. And to rephrase Dr. Melvin Conway, he it would be this. And this is actually framed by Eric Raymond, who's famous for his book, The Cathedral and the Bazaar, about open source. And Eric Raymond rephrased Conway's law to say, if you have 4 groups working on a compiler, you'll get a 4-pass compiler. So this actually has some significant implications to how we do work in the technology value stream when we have to span developing, testing, operations, and security. But one of my favorite stories and case studies in the DevOps Handbook is about the birth and death of Etsy Sprouter. So Sprouter, essentially the story begins in 2008 when, in order to develop and deploy new functionality, especially one that included any sort of business logic, it really depended on 2 teams. There were the front-end developers that were working in PHP, and then there were the DBAs. And so this meant to develop any new code would involve 2 teams having to perform work. So if you go to the first build, Araya, we can see that's 2 teams, the developers and DBAs. But the problem is that caused considerable friction. So in the next slide, Araya, what they did is they created a technology called Sprouter. That's short for the Stored Procedure Router. And the inspiration for this, or the idea, was that the developers would work independently, as could the DBAs in the stored procedures and Postgres, and then the Sprouter technology would help them meet in the middle. The problem is now we went from having 2 teams having to do work to deploy functionality to 3 teams having to do work, and as was framed in a famous presentation about this. They said it required a degree of communication and coordination that was rarely achieved. In other words, every deployment became a mini outage. And so this is an example of how Conway's law actually prevented them from Sprouter from achieving the desired goals. And so they, as part of the Etsy transformation in 2009, they said, we were going to kill Sprouter. And so the goal was to be able to have all the business logic changes be done by developers. So in the next slide, the next build, the goal was for all business logic functionality to be able to be changed. Next build, Araya, by the developers in PHP. They built an object relational model for PHP to MySQL so that developers could independently develop, test, and deploy value without having to depend on any other teams. The outcome of this was that they were able to increase the reliability during deployments, they were able to decrease the lead times to get into production, and they were able to increase developer productivity. So I love this example just because it shows a very concrete example of how Conway's law can hurt us, as well as how Conway's law can help us. And so the goal is, how, again, this is not just architectural, this is an architectural decision and influences the technology choices that we make. So that was one of my favorite case studies in the DevOps Handbook, and it was actually one of my top learning. It was one of the biggest aha moments I had in the last 3 years. So let's go on to another big surprise. Araya, this is the title slide of Decoupling Deployments from Releases. I had read the Continuous Delivery book by Jez Humble many years ago, and I thought I had understood this concept, but I was having a conversation with one of my co-authors, Jez Humble, and I realized I had not fully internalized how profound this principle is. And so let's go down to the next slide. The story that I think that exemplifies this the most is the Facebook chat study, a case study in 2008. And so I think many people roll their eyes when I bring this up because it sounds like a very simple problem. In fact, undergraduates will write chat servers often as part of their probably sophomore level computer science training. But at the heart, this is an order n cubed algorithm. And so when n is as large as 75 million simultaneous users, as in the case of Facebook, this is a tremendous technical undertaking to be able to deliver. This actually took them 1 year to do. By many accounts, this was the largest technical problem that Facebook had ever undertaken. It was one of their largest project teams. It was their first use of Erlang on the back end. It involved many, many different parts of the technology stack. So what's astonishing is how they used that year. And the most significant part of this was that from the very beginning, as soon as they constituted the chat team, any code they would write would be checked into the source code repository, into trunk. Whatever was in trunk would be silently migrated into the production environment at least once per day. So instead of doing deployments only at midnight and having the ops people work all weekend, trying to get things running before customers notice that it's not working on Monday morning, they're doing it in the middle of the day without causing chaos and disruption, and being able to tap everybody's help because everyone's already in the office. So the notion of this is that we are deploying every day. When they released the code into functionality, they went from 0 users to 70 million users practically overnight. Part of which was enabled by testing in production for nearly a year. So to explain that, so essentially they were using every Facebook browser user session as a testing harness. So when every person logged into Facebook, that client would be sending chat messages to that invisible backend service. The reason they would do this is so they could simulate production-like loads. Even the notion of being able to generate enough traffic to simulate 70 million online users was made simple by having every client, being a part of this testing harness. So, that's certainly a game changer, right? Is that we can detect performance issues long before the release. That means we can actually fix issues when we have the most amount of freedom to fix it. But let's go back to this notion of a daily deployment. So imagine for a year that we're slowly and constantly accumulating all the code necessary to actually run Facebook chat service in the production environment. And the release event is simply a configuration change. So by doing this, we have fully decoupled the deployment from the release. The deployment is something that is happening every day where we're accumulating all the code changes needed to deliver the functionality. And the release event is that one configuration change that enables the service in production. And incidentally, if it doesn't work, we can undo that configuration change and then silently revert back to the known state. So by doing this, in theory, we can reduce the deployment risk to nearly 0. And now the only risk is the release risk, is did the feature achieve the goals that were intended? And so by doing this, we can hold dev and ops accountable for the silent and smooth flow of code into the production environment, and we can now hold product owners responsible for did it achieve the desired customer and business outcomes. So I think that was certainly one of the big ahas that just crystallized while we were working on the book. Maybe just one last metaphor, just in terms of how my mental model for deployments versus release. In the 90s, there was the Operation Desert Shield, where we were deploying thousands of men and materials into a staging environment that took 6-7 months, but there was one release event, which was the initiation to transition from Operation Desert Shield to Desert Storm. So again, two different activities that, at least in my experience, I've conflated the two, and so it's very powerful to decouple and not to disambiguate the two. All right, let's go on to the next big learning for me, which is the importance of measuring code deployment lead time. In the next slide, Araya, I think in the DevOps community, as I mentioned before, is one of our favorite metrics is probably deploys per day. We know that Etsy did 10 deploys a day. We know that Amazon is doing 136,000 deploys per day. But in the lean community, in manufacturing, that is obviously not their favorite metric. Their favorite metric is in the next build, Araya, lead time. And they would measure lead time by how quickly can we go from raw materials at one end of the plant to finished goods at the other. And would you believe that there's this deeply held belief that goes back 30, 50 plus years that says lead time is the most accurate predictor of internal quality, external customer satisfaction, and even employee happiness. And what we found in our benchmarking work, spanning 26,000 respondents, is that that's absolutely true for the work that we do as well. And so in the next slide, Araya, we specifically measure lead time as this. How quickly can we go from code committed in our version control repository through some sort of testing process, through a deployment process, so that we are running in production successfully. And that probably begs the question, why do we start the lead time clock there? Why don't we start it earlier in the life cycle, for such as when developers accept a feature to go into work, or when an idea is actually conceived? And the reason we look at the code commit point is that that's actually the dividing line between two very qualitatively different parts of the value stream. So on the next slide, Araya, we can see that to the left of code committed is the design and development part of the value stream. So in design and development, we are often doing work for the first time, never again to be repeated. So the result is variance curves that are very low and flat. So it's in other words, because we never get a chance to do something twice, right? The variability of how long it takes is very unpredictable, and very unpredictable. Whereas in the next build, Araya, to the right of code commit, we have testing and operations. And in testing and operations, we want the exact opposite. We want testing and operations to happen quickly and the same time every time. We want it to be, and the reason for this is that we want to create the fastest feedback to developers, ideally every time that a change is committed to version control. So to highlight why this is so important, consider the case where a developer checks in code into the repo where there's an error. If they only find about the error 6 months later during integration testing, then the link between cause and effect is most likely lost, and the ability for that developer to learn from that mistake is significantly diminished. In the ideal, we want testing to be able to find errors within minutes, or worst case, an hour after that code is actually introduced into the production environment. And so what's amazing is that code deployment lead time not only predicts the effectiveness of the testing and operations value stream, but it also predicts how quickly can we create feedback, to design and development. We want them to be able to find errors quickly, and there's also gates how quickly we can get feedback from customers. And so whenever we want to experiment, do customer experiments, code deployment lead time, fast code deployment lead time is required. So what looks like a very tactical measure, it turns out to be one of the most strategic measures of any technology organization. So in the next slide, Araya, we can see that code deployment lead time really predicts all sorts of wonderful things, not just IT performance metrics and organizational performance metrics. Araya, in the next slide, it also predicts all these other things that we know predict performance. It predicts whether Dev and Ops have a common source of truth, right, by having a shared version control repository. It predicts whether we have effective automated testing in the deployment pipeline. Next build, it predicts how, next build, Araya? It predicts how quickly we can actually deploy into production without causing chaos and disruption. On the next build, Araya shows us how quickly we can detect and correct problems. In other words, how good is our production monitoring. It predicts whether there is a sense of a genuine win-win relationship between dev, test, and ops. And on the last build, we see that it also predicts how quickly developers can get feedback on their work. So, I guess as if that learning weren't enough, this is even punctuated by the learning on the next slide, which is that we found in the benchmarking research 2 years ago was that there's one question that can predict all of this: code deployment lead time, IT performance outcomes, the presence of all those great behaviors that I talked about in the last slide. And then Araya on the next slide shows what that one question is, and specifically that is, on a scale of 1 to 7, to what degree do we fear doing deployments? 1 is we have no fear of doing deployments at all, we do them all the time, whereas 7 is we have existential fear of doing deployments, and that's why we do them never. Right? So, in fact, we are so afraid of doing deployments that this year is just not a good year to do deployment. We'll do it next year, which actually worsens the outcomes. So, I think that is just a phenomenally powerful question. Is that if you can ask people around you and your organization, that actually is a phenomenal predictor of not just the technical practices and the cultural norms and the architecture, but it also predicts the IT performance and organizational performance outcomes. Oh, and incidentally, that also predicts the security outcomes as well. All right, so let's go on to the next big surprise, which is the role of testing and information security in the DevOps value stream. On one of my favorite stories in the DevOps Handbook comes from Elizabeth Hendrickson. So let's actually show the next slide, Araya. I love this quote, and so maybe just to tell you why Elizabeth Hendrickson is one of my heroes. She's an author of the book called Release It. Oh, no, I'm sorry, Test It. And she is now the VP of Engineering for the Big Data Suite at Pivotal. Before that, she was a Senior Director of Engineering. Before that, she was a Director of Quality. Just really showing, I think, the ascendancy of, how important, testing is in any engineering profession. And she told me the story where in 2011, for the Cloud Foundry project, they had this big problem. Their biggest problem was that it would take, in order to test a change in the Cloud Foundry platform, it would require deploying to 45 different virtual machines, and that would take a half hour, right? And then for her, that was way too long because it prevented developers from being able to test on their own workstations and get fast feedback on their work. And so because of how, and by the way, the reason why I'm laughing is that I think many of us would die to be able to test that quickly. Many of us are in situations where in order to do acceptance testing or integration testing, we have to wait weeks or months to get into the integration test environment. So, 45 minutes, 30 minutes sounds amazingly fast, but for her, that was too slow. So, because of this, this was the impetus for essentially putting the entire Cloud Foundry platform into containers. They got it down to 18 virtual machines, which was low enough so that any developer could run the entire Cloud Foundry platform on their workstation and be able to spin up an entire new environment within 6 minutes. And she credits that for a dramatic increase in developer productivity at Pivotal Labs. So I think this is just an example. And so there's another story that is in the DevOps Handbook that's very similar to this. Rohan Singh, he is a dev manager at Spotify, and he said, our unit test coverage is so good that we rarely find, errors that could be caught in unit testing because they've done such a good job in that. Instead, they find the majority of their errors, in the integration environment. It's when we have to test our modules with other modules and other external dependencies. And he said, in order to get to their development outcomes and operational outcomes that they wanted, they put the entire Spotify environment into containers so that every developer is not only writing and running unit tests, but they're also writing and running the integration tests on their laptops. And so I think this just shows, not only does testing not go away, but it's really an example of how we need to integrate testing into the daily work of everybody in the value stream. Oh, you know what? I actually forgot a slide here. And the same thing applies for information security. I love it that at Capital One, they don't call it DevOps there. They call it DevOps Sec. And I love this because it shows how they are integrating the information security objectives into the daily work of everybody in the value stream. So in the ideal, all our preventive controls, like the correct configurations of libraries and platforms, and the pre-bust libraries, like that supply two-factor authentication. Those are all in a shared source code repository. Alongside our automated testing, we're running static code analysis, so we can find vulnerabilities before it gets into production. And alongside proactive production monitoring, we're running dynamic testing, so we can find vulnerabilities before attackers do. And by doing that, we are making information security a part of everybody's job every day. So I think many people perceive that DevOps represents the death of testing and information security, and my feeling is that the exact opposite is true. That by DevOps really makes everybody responsible for the testing and security objectives as well. Okay, right. Let's go on to the next slide, which is, I think actually a very big aha moment, and that DevOps is probably a subset of a larger category of organizations that researchers call dynamic learning organizations. So Orion, the next slide. I think one of the best people who's written about this is Dr. Steven Spear. I think one of his many claims to fame is that he wrote a very seminal Harvard Business Review article called Decoding the DNA of the Toyota Production System. And essentially, this was based on the doctoral thesis that he did at the Harvard Business School. And as part of his journey, he worked on the Toyota assembly line for 6 months on the plant floor. It was actually on the plant floor of a Tier 1 Toyota supplier called ASIN. And so he went on to extend his work beyond just the Toyota production system to building the safety culture at Alcoa, the U.S. Naval Reactor Corps that delivered 3,500 accident-free operating hours in the U.S. Navy, the engine design team at Pratt & Whitney, many, many others. And he said that while designing perfectly safe systems is likely beyond our abilities, safe systems are close to achievable when the 4 following conditions are met. And so, by the way, I took his workshop at MIT. This must have been 2-3 years ago. And when during that class, it was just one of a truly huge aha moment. And it was, so what I'm going to do is show what those 3 capabilities are and point at some specific technical practices that we see in the DevOps community, but I'm going to highlight one of them just because in my mind it was just a big blind spot, at least for me. So Araya, on the next slide, as I mentioned, there are 4 capabilities. The 4 capabilities begin with capability 1. Spear asserts that we have to design and operate work, manage that work so that problems in design are revealed all the time. So we have to see problems as they occur, and that happens through the relentless testing of assumptions. So Araya, on the next slide, on the next build, I think the activities that we would recognize in the DevOps community would be like assertion statements in code, automated testing that's happening all the time, ideally before production, the notion of proactively monitoring everything in the production environment. And so the notion is that we want everything in the deployment pipeline, everything in our service to be constantly radiating telemetry so that we can actually see how it's behaving, not just in our production environment, but in the deployment pipeline. So that's capability 1, see problems as they occur. So right, we can go on to the next slide, which is capability 2. It's not enough just to see problems. We need to be able to swarm those problems immediately, not just to solve the problems, but to build new knowledge. And we can only do this when we prioritize the improvement when we prioritize improvement of daily work even above daily work itself. So in the next build, Araya, we can see some technical practices that match this. This is the notion that we stop work when things go wrong. So very much like the Toyota and-on cord, where if you pull the cord when something goes wrong, the entire assembly line stops. We want the sort of same behaviors when our continuous builds fail, right? And we might not stop all work, right? In other words, everyone on the team might not have to stop work, but the notion is that whoever broke that build, right, the most important thing for them is actually get that build running again. If someone breaks an automated test, the worst thing that can happen is that person goes on and does more things that breaks more tests. Instead, we have to prioritize getting back into a green state. Same things when deployments break or if services go down. And all of what this does is that not only does it enable fast feedback loops, but it improves the system itself. By doing this, we are actually improving daily work. So capability 3, which is on the next slide, Araya, for me this was a big aha moment, was this notion that Spear asserts that there has to be some mechanism that turns local discoveries into global knowledge. In other words, when new practices, when new great practices are created, there has to be some way to integrate that into the entire state of the practice. So in the DevOps value stream, Araya, the behaviors that this points to include the notion of high trust culture, the notion that we need to create a cultural norm that's safe to talk about problems, because it's only that enables honesty, and it's only that honesty that can really enable prevention. And one of the practices that we talk about in the book is the blameless postmortem. Is that there's a ritual that's famous. At Etsy they call it the blameless postmortem. At Google it's known as the blameless post-incident review. But the goal is to enable each team and each engineer, when something goes wrong, to establish an honest, accurate chronology of what happened. And this enables us to actually generate the right countermeasures so that we can prevent it from happening again. And what I love about, there's a quote in the DevOps Handbook that I love, is like, that came from HubSpot. They said, the answer can never be, we must be more careful in the future. We must always plan for a future where we are as stupid now as we were, that we were going to be just as stupid in the future as we are now, right? So being more careful is not an effective countermeasure. Instead, how do we redesign the system so that we can actually genuinely prevent that failure from happening again? Another key practice is the notion of a single source code repository. Google is famous for having every Google property all in one source code repo, and it's due to a happy accident that because Google Search back in 2005 was a statically linked C++ compiled binary, there was only one version of each library allowed. So contrast that to a friend of mine where he said there are 93 versions of the Java struts library, and we are running 91 of them in production, right? All but one insecure. So think about the organizational drag that's created by having to support 91 different versions of Java struts in production. So, having one version allows a consistency, but more importantly, it represents the collective knowledge of how things should be designed and configured so that it runs best in production. And it's so important for ops and security to embed that knowledge, not in their heads, not in a Word document, but instead in our code repositories. Internal conferences, all of these represent capability 3. So, there was I say somewhat jokingly that, it was that workshop, capability 3, that really set back the DevOps Handbook by 2 years as we had to rethink, what DevOps really represented. And I'm so grateful for that time we took to get it right. Capability 4, Araya, says that, let's go on to the next slide. We can build this out to the next slide. Thank you. Here's a good example. Actually, we'll just pause there. Google is probably an exemplar of what happens when you do this right. They have 15,000 engineers, 4,000 projects, one shared source code repository, and that consistency allows them to do 5,500 code commits per day, and they run 75 million automated test cases daily. All right, let's go to capability 4. All right, that's thank you. One more build. So essentially what this says is the job of leaders is not to command and control, but it is to create other capable leaders that can perpetuate this system of work. And Heather Mickman at Target, she told me a lovely story. She said on their first, they had a new CIO come in from Tesco, and he said on his first week on the job, my goal is not to direct and to control, but to guide and enable. I just love this because it really does describe that, I think that era of command and control and low trust bureaucratic processes is probably coming to an end. And this to say that really, the goal of leadership is to create the conditions where organizational learning can happen, and it really happens through guiding, enabling, and helping remove obstacles so people can actually do their daily work. All right, so that's one big surprise, right? Is that DevOps is really a subset of this larger category of organizations called dynamic learning organizations. The last surprise I want to share today is on the next slide, Araya. DevOps is not just for the unicorns, but on the next slide, Araya, we learned that DevOps is for the horses as well. So it's not the unicorns of just Amazon, Google, Etsy, Facebook, Netflix, but increasingly it is for large, complex organizations. And Araya, on the next slide, you can see that large, complex organizations are deploying the same principles and practices and getting the same sort of amazing outcomes that we see have typically only associated with the likes of Google and Amazon. So to really learn how these organizations are transforming was the reason why I've hosted a conference called the DevOps Enterprise Summit, now going into its third year. And this is where we invited leaders from large, complex organizations to describe the stories of their transformation in a very specific form about, tell us about the organization and the mission. Where do you fit in the org chart? What was the business problem you're trying to solve? Where did you start and why? What did you do? What were your outcomes? What did you learn? What obstacles do you still have left remaining? Because as I think adult learners, we don't learn from theory and stories of what people think they want to do. We learn from concrete examples of what people did and what their outcomes were, like the scientific method. So in the next slide, Araya, I want to share with you my top 2 surprises that came out of that journey. One was there's just no doubt that large, complex organizations are getting the same sort of amazing outcomes using the same principles, patterns, technologies that we typically only associate with the unicorns. Heather Mickman, the director of development at Target, she described how, yeah, they're doing DevOps internally with lots of deploys, but what is amazing is what they're doing DevOps on. They are the business problem she was trying to solve was this. Any time that a development team wanted to get access to store information, product catalog, create orders, shipments, cross shipments, they would often have to wait 6 to 9 months for the dev team, for the system of record teams to get ready. And so to solve this problem, they put all that information into a next generation system of record in Cassandra, Redis. They had stable versioned API so that any team wanting this information could get that access, could add, remove, update this information on demand. And so they credit this capability for enabling 53 different business initiatives over the last 3 years, including the Starbucks integration, the ship-to-store integration, one of the most strategic capabilities for any retailer competing against Amazon, the Pinterest integration, the in-store apps, 53 initiatives. So just think about all that productivity that enabled. The next build, Araya, Toporada Pal described how they create a shared deployment service with security and testing built in, enabling teams across Capital One to do hundreds of deployments per day with lead time not measured in months but in minutes. Next slide, Araya, sorry, next build. Gary Groover talked about how they went from doing 1,500 manual tests every 10 days to now doing hundreds of thousands of automated tests daily. The next slide, Jason Cox described how he's embedded nearly 100 ops engineers into dev teams across the Disney enterprise, helping those teams become as productive as if they were at a Google or an Amazon. Carmen Diardo talked about, from Nationwide Insurance, described how they did DevOps for their state pension retirement funds application. It's a 40-year-old COBOL mainframe app. They're a market segment leader, just showing that you can do this for COBOL applications, even when you're leading the market already. Terry Potts on the next build, Araya, talked about how they reduced the testing and certification time for ground control stations that control satellites from months down to a day. So all of these examples, I think, really give us confidence that DevOps principles and patterns really transcend the technology that we're working on. It really is universally applicable. So on the next slide, Araya, I want to share my second surprise, big learning, which is, and one more build, is that these stories are some of the most heroic I've ever heard. In other words, even though each one of these leaders were given some degree of air cover by management, I think every one of those leaders wildly exceeded the air cover they were given. Why? Essentially putting themselves into some degree of personal jeopardy. So why would they do that? And I think it's what every speaker had in common was they had a sense of absolute clarity and conviction that it was the right thing to do for the organization. That in order for their organization to win in the marketplace, or maybe even survive in the marketplace, required elevating the state of the practice in their organization. So it has been an honor and a privilege to be able to chronicle their journeys, because I think it is they're such amazing, courageous technical stories that would fit right at home in any Velocity conference. So, Araya, on the next slide, why do I think this is important? On the next slide, I think it's for a couple of reasons. One is that the downward spiral there's a downward spiral that exists in every organization. Left unchecked without something like DevOps leads to horrendous outcomes, whether we're in dev, test, operations, even information security. But the ultimate organization that's harmed is the organization that we serve. And so we need DevOps to break that downward spiral and get the amazing outcomes that we now see in both the unicorns and the horses. And I would say there's another reason that's emerged for me over the last couple of years, and that's really emerged through the work in the DevOps Handbook, is that I think the mission at hand is to elevate the state of the practice. IDC says there's 8 million developers on the planet, 8 million ops people on the planet, and the vast majority of those engineers, they're not working in a unicorn organization. They are working in every large brand and every industry vertical, spanning profit or not-for-profit. And I think the mission really is, how do we elevate the state of the practice so that every dev and ops and security and test engineer is as productive as if they were at a Google, Amazon, or Netflix. And so, there's no doubt in my mind that the value created by that will be measured in the trillions of US dollars, probably per year. And so it is a mission definitely worth undertaking, and DevOps is part of that. All right, on the next slide, to summarize, these are some of my learnings in the 5+ year making of the DevOps Handbook. I'm so grateful that I was able to work with my fellow co-authors, Jez Humble, Patrick Dubois, and John Willis. I genuinely hope that everyone will think it's worth the wait. There are 48 case studies in here, many of them based on the case studies coming out of the DevOps Enterprise Summit. I am especially proud of the statistics of 503 endnotes, 192 footnotes. We'll be publishing out all of the citations that came out of it, because it in and of itself is just a phenomenal resource for me in terms of the corpus of knowledge that went into this. So if you are interested in any of this, on the next slide, Araya, here's a way to learn more. If you want a copy of this presentation, if you want a free 140-page excerpt of the DevOps Handbook, which is actually launching officially, I think, on October 9th. So it'll be 2 weeks until the book is out. We'll have instructions on how to pre-order the book. If you want a 140-page excerpt of the Phoenix Project, if you want the video and slides from all of the DevOps Enterprise conference talks from 2014, 2015, and 2016 in London, with a conference 2016 in San Francisco is coming up. An hour excerpt of the Phoenix Project. All you have to do is send an email to realjanekim@sendyourslides.com with the subject line DevOps. And if you do that, you'll get an automated response within a minute. With that concludes the prepared part of my presentation. And let me turn it back over to Araya. Thank you so much. And I think we have some time for Q&A. Is that right? Araya, are you still there?
Yes, sorry.
Okay. Well, let me...
If you have any questions, please, you can just write them in the chat box, in the question box, please.
Very good. Well, I see one question about automated testing. Is there a specific learning about that? One of my favorite stories in the DevOps Handbook, I keep on saying one of my favorite stories, there's so many great things that went into the book. It came from Mike Bland. I asked so many people at Google, where did this amazing testing culture come from? Everyone that I asked said, I don't know, it was sort of here when I got here. So I actually brought up that question with to my friend Jez Humble, co-author, and he said, oh, I think I know the team who did it, and he introduced me to Mike Bland. And so he was a part of a team that transformed Google culture in 2005. So the problem was that deploying to google.com in 2005 was a very dangerous thing. it was actually it was called the GWIS team, the Google Web Services team. And it was sort of the dumping ground of everybody's sort of half-baked, half-tested code where development teams would just push stuff onto Google.com, and invariably would cause, if not site-wide outages, which actually happen very infrequently, but it caused a lot of other problems. It would, searches would break, you get infrequent search results, and all these things would affect revenue. And there was this amazing story of how they decided, to enforce automated testing. In other words, over the course of many months, they actually got to a point where no code could be deployed onto Google.com without associated automated tests. And they rapidly went from probably the worst performing, least reliable group inside of Google to the best performing. And so so that significantly increased the reliability of Google.com. But then the heroic part of the journey began when this team tried to expand that practice across the Google organization. And probably one of the most famous stories associated with that is called testing on the toilet, right? They went on a massive propaganda campaign, putting flyers onto every bathroom stall, talking about automated testing, teaching, volunteering to help. And over the course of 3 years, they described this journey where they elevated state of the practice across the entire Google organization. And the outcome is what we see now, right? 75 million test cases running every day, 5,500 code commits, all of it passing automated tests. So it's just a phenomenal story that came out of the DevOps Handbook. I see another question. Can you please share your learnings on DevOps in any IT service-based organizations based out of India? There was actually a submission, I think, that we will be putting on next year that's coming from a team that's actually supporting the Tesco organization with a large component in India. There was actually a talk that was given at Marks and Spencer from DevOps Enterprise 2014. I will try to send you, I'll get you a link to that slide, and I'll send that to Adele and Araya, and then we'll get that answer to you hopefully in an email. So thank you so much for the question. Adele, I think, Araya, I think we have time for maybe one more question. Is that right? I assume yes. Is there anything else that I recall in terms of sort of another big surprise? Yeah, I guess this is so new that it didn't. There's not a whole section dedicated to it, but hopefully it's punctuated enough places where people will appreciate it. I think there's a sort of an ethics to DevOps that I think is important. So much of the old way of doing things is just is terrible for humans in general. This, in other words, there's a certain lack of the more humane work to do technology work is in the DevOps practices. I think the days of having to have people working all weekend, week after week after week, doing deployments, right? The notion of people have a sense of duty or obligation or because they didn't have a choice. I think we now know that there's a better way, and so we see this in the benchmarking as well. We find that the rates of burnout are lower in high performers. The employee satisfaction is higher. In fact, in the 2016 study, we actually found that in high performers, employees were 2.2 times more likely to recommend to friends their organizations as a great place to work. So I just, as I think anyone who cares about people should also care about DevOps and know how DevOps can improve the lives of the people that they're responsible for. So with that, that concludes the prepared part of this presentation and Q&A. Thank you so much to Araya and Adele and eSynergy. If you did that send your slides thing, if you reply to that email, it will go straight to me. So please let me know if there's anything I can do for you. And thanks again to eSynergy, and thank you all for listening.